In class, we looked at the Caesar cipher, and we thought of it as being in a circle where we had an outer circle of the alphabet, and then we had an inner circle of the alphabet, and then we would have this idea of a key. And so the key would tell you how many letters to shift. So if my key is 2, I'm going to want to rotate that inner wheel to the right, 2 letters to the right. And then if I want to do an encryption, I would look at my inner wheel to get the letter, and then look across to the outer wheel to get the encrypted text. And then if I wanted to decrypt, I would look at the letter I have in my already encrypted, coded up text, and then I would look to the inner wheel to see how to decrypt that letter. Well, now that we have to code this, it might be easier to think of it more as being in a linear form or a list form. So we would have the entire alphabet in a list or in a string, especially if we're coding this in Scratch, which we are. So if you think of a string of the alphabet, and then you think of each letter of the alphabet as being a number, and Scratch provides a little operator that lets you take letter I of a string. So if you took letter 1 of this string with the alphabet, you would get an A. If you took letter 12 of this string, you would get an L. So it's a way of getting to all of our strings there. So this would represent one piece of the alphabet, but that's one part of the message. There's another part of the message, and actually that bottom level of character string, that is kind of what you can think of as our original text. So if I have a key of 2 here, I'm going to move the list 2 to the right, and so that bottom list, if I look at the letters there, so if on the bottom list, look at the A, and then look up 1, and you'll see that A will encrypt into C. If you look at the bottom list and pick an L, and then look up, L would encrypt into an N using that key of 2. And then if you wanted to decrypt, you would look at that top row and look down. So that would be a way to do what we did in a circle, doing it in a list or a string form. So we're using that location in the alphabet plus the key. So we're adding that key number to the location in the alphabet to figure out that encrypted letter. So let's look at an example. If I wanted to encrypt the word hello, and if I use key 2, we're going to add 2 to that letter's number. So H is the 8th letter in the alphabet, and I can see that by looking at the top row of my alphabet string. So we look 2 more to get to the 10th letter. So I take 8, I add 2, I get the 10th letter, and that's a J. E is the 5th letter in the alphabet, so I'm going to shift to the right 2. So 5, instead of looking at the 5th letter, I'm going to look at the 7th letter, which is G. And then L is the 12th letter, so I'm going to add 2 to that to get 14, and that gives me the letter N, and I'm going to do that twice because there's 2 L's in the word hello. And then O finally is that 15th letter in the alphabet, so since I'm encrypting it with a key of 2, I'm going to add 2, and that gives me the letter Q. So we're using that key 2, hello encrypts into those characters there, the J, G, N, N, Q. So that is one way of thinking about it in a list form. So what happens though if when I add my key, right, how many to shift, I get a number that's bigger than 26. So if you look up there, like letter Z is a 26. And what if I want to encrypt that? Well, if I add 2, I'm kind of off my little chart here, and that's bad. Well, we'd have to wrap around to get back to the front of the list. So if we want to encrypt, say, the letter Y with a key of 2, I need to get to letter A, right? The first letter. So really what my string that I'm encrypting to should look something like this, right? Now the way we can get there using code is to use something called the modulo function. And this is a math function or operator that's existed. You probably haven't heard of it. Now this is where it starts getting a little bit tricky, and this really is intended for the most advanced coders that I have in class who are really curious about how things are done. Otherwise, feel free to just take my code as is. But if you're curious, like what is actually going on in there, listen on. So what is that modulo function? Well, the modulo function, sometimes called the mod function, can be thought of as the remainder when you have two positive integers involved with mod. So what in the world does that mean? So let's look at some examples. So if I take 6 mod 3, I'm going to get 0. Well, why is that? Well, you basically look at 6 divided by 3, or you can think of how many multiples of 3 are there in 6. And there are 2 multiples of 3 that make up 6. So I'm not going to have anything left over. It works perfectly. So that's a 0. But if you think about 7 mod 3, well, there are 2 multiples of 3 in 7, right? 3 times 2, right? 6. But if I subtract that 6 from the 7, I'm going to have 1 left over. So 7 modulo 3 is 1. And you can think of it as the remainder if you did 7 divided by 3, right? You'd have 2 remainder 1, so that's 1. But this is kind of a tricky looking one. What about 6 modulo 7? And that basically asks, well, how many multiples of 7 are there in 6? Well, there aren't any. There are no multiples of 7 in 6. So how many will be left over if I try to take, how many multiples of 7 in 6? What's going to be left over? There's going to be 6 left over if you take 6 modulo 7. Now this, I understand if you're kind of scratching your head at this. It's kind of a strange little operation in math. And if you've never seen it before, it's a little bit weird, so you're going to have to think a bit about it. So let's see how this can help us, though, with our Caesar cipher. So what our Caesar cipher code needs to do is to, as we said before, find that location of the number we want. And then what we're going to do is add the key, and we talked about that before, but we're going to take that sum and we're going to say modulo 26, because there's 26 letters in the alphabet. What? Well, let's look at an example. So let's say I want to encrypt the word boy, and I'm going to use our key 2. That's what I'm using in all our examples here. So B is letter 2 in the alphabet, and I put my little chart there on the bottom. So B is letter 2 in the alphabet. I see that in my front row. So I'm going to add 2. And I add 2 to that second place, 2. So I now have 4. And if you look at position 4 on above, or if you use that kind of bottom row to kind of see that B is going to map to D, you can see that's what's supposed to happen. But how do I tell code to do that? Take 4 modulo 26. Well, how many 26s are there in 4? There aren't any 26s in 4. 0. But I'm going to have remainder now of 4. So that tells me that I'm going to use letter number 4 on that top row there. The 4th letter is D, and I've got my first encrypted letter. Then I have to look at my second letter, which is O. I want to encrypt that, and I can see in my chart here, O is the 15th letter in the alphabet. That's in the first row. So I know from the bottom row that I really want to get to 17, that O has to kind of become Q. So how do I do that? First, add the key, 15 plus 2, that's 17. And then take 17 modulo 26. How many 26s are there in 17? None. There aren't any 26s in 17. So I'm going to have a remainder of 17. So that says look at letter 17 instead of 15. And that 17th letter is Q. So now we have our second encrypted letter. And then finally, we have Y. Now, Y is letter 25. If I do what I did before, which is add the key, 25 plus 2 is 27, I've run out of alphabet. But here's where the modulo can help me. So 27 modulo 26, well, how many 26s are there in 27? Well, there's one grouping of 26 in 27. But how many will be left over after I take that grouping out? I'm going to have 1 left over. And so what's the first letter in the alphabet? That's A. So that is telling me that my last letter encrypts to A. So encrypting letter boy using key 2 is DQA. If you got that, you are amazing. Let's look now at decryption. How do we go the other way? Well, to go the other way, instead of adding the key, we're going to be subtracting the key. So how does that work? So we're going to take that actual location number in the alphabet, we're going to subtract the key, and then we're going to modulo 26. So let's see what happens here. So in the previous example, we know what DQA is because we encrypted the word boy. Well, how do you go backwards if somebody wants to decrypt this knowing that the key is 2? Well, let's try it. D is letter 4 in the alphabet, right? And I'm looking at the top row in my little chart below, 4, right? D is 4. And then you could look below and see it's supposed to go to B. So how is the code going to get there? So I'm going to subtract 2, my key, from the letter number 4. I get 2. And then I'm going to take 2 mod 26. Well, how many 26s are in 2? None of them. So how many left over? 2. So the second letter is B. The second letter in the alphabet is B. So I found my first decrypted letter. Let's look at the Q. Again, encrypted there. That's a Q. That's the 17th letter in the alphabet. So do the same thing. Let's subtract the key this time. We're getting 15. So if I take 15 modulo 26, there are no 26s in 15, so that's 0. But I do have 15 left over. So I want that 15 letter. The 15th letter in the alphabet is O, so I found my second one. Now here's where it's going to get really tricky. Okay, so A is letter 1 in the alphabet. So if I subtract the key, I get 1 minus 2, which is negative 1. Now here's the problem. When my modulo numbers start getting negative, it's harder to see what's going on. Much harder to see what's going on. And so if I want to think about going backwards, I think it's very difficult to explain this without kind of drawing all kinds of pictures. I'm going to ask you to come talk to me if you want a more full explanation of this. What I'm going to tell you right now is think about something like a clock. So if it was 1 o'clock on a clock, and I said, what's 2 hours before 1 o'clock? I think you immediately know that's 11. So if I'm thinking about, well, what is one letter before I get to 26? That I'm going to go backwards, and I'm going to get to 25. And so maybe if you think of it more the way a clock works and how we tell time, if we want to know what happened a few hours ago, maybe that will help see why if I'm taking negative 1 mod 26, I'm going to the left 1 there. And it's saying use number 25, the 25th letter in the alphabet. And the 25th letter in the alphabet is Y. And that's how I get that. So there you have it. It's hard. I know it's hard, especially 7th grade. This is well beyond the math that you have had, that most of you have had. If you were able to follow even a little bit, that is just fantastic. So you feel free to use my code that does this, but if you do dive in there, hopefully this helps you see what's going on. And as always, feel free to ask me if you're really curious about this and this just didn't get it for you all the way. Thanks again for watching.